Welcome to qnawire.
So now we'll work on problem 70 from chapter 20. In this problem, we're told that a voltaic cell is constructed with two silver chloride electrodes, each of which is based on the following half reaction. Silver chloride plus an electron will produce silver and chloride. The two half cells have Cl minus equals to 0.0150 and 2.55 molar respectively. First, they want us to tell what electrode is the cathode of the cell. So let's go ahead and write this reaction here. We have silver chloride plus an electron will make neutral silver and the chloride ion. So first we need to know which electrode is the cathode and which is the anode. So at the cathode, reduction will occur. And when a reduction is occurring, this reaction is occurring as is written, as opposed to the reverse reaction, which will occur at the anode. So the reduction at the cathode will occur at the electrode in which we want to go to the right, in which we have less chlorine. So the electrode in which we have less chlorine is the one with 0.015 molar is equal to the concentration of chlorine. So since we have less chloride ion at this electrode, the reduction will occur here, making it the cathode. In part B, they ask us what is the standard EMF of the cell. And if we look up this reaction in our appendix, we get 0.22 for this reduction, but we also have 0.22 reverse reaction for the oxidation, so we have a value of 0 volts for the standard value. Now they ask us what about the conditions that they specify? And for that, we need to use the Nernst equation. So we have E naught, which is 0 volts, minus 0.0592 divided by N, which is 1, since we're transferring 1 electron. And then we have log of the concentrations. So since the two concentrations that we have are chlorine, we just need to figure out which will be a product and which will be a reactant. So since the reduction is occurring at the cathode with 0.015 molar, that means it's the product. We're having this as the product and we're consuming the chlorine at the anode as a reactant. So we have 0.015 divided by 2.55. So we do this calculation and we get a value of 0.13 volts. The last part of this question, part D, asks us, for each electrode, predict whether chlorine will increase, decrease, or stay the same as the cell operates. So, as we mentioned before, at the cathode, we're producing chlorine. So in the cathode, chlorine concentration will increase because we're producing it. And for the anode, chlorine concentration will decrease because it's being oxidized, or silver is being oxidized at that electrode.